Ethereum. What is it and why should you care? How would it be relevant to you? The first fact is that economies are based on trust. My employer trusts that I'll do the job as assigned, and that I won't do anything that would make the employer's customers mad with us. I trust that after I do the job, I'll get paid. And we both trust that the economy will continue and that the money that I earn and the money that the employer gets from the customers will stay valuable. Otherwise, there won't be any point working for it. Every time that there's trust, there is always the ability to abuse the trust, and there is always some reward that you can get for abusing the trust. So, as a society, we have developed mechanisms to enforce this trust. For example, credit reports that show whether it's worth it to let you borrow money or not, courts that deal with contract violations, and regulatory bodies that make sure, for example, that banks and insurance companies don't bet too wildly with their customers' money. There are two types of trust if you think about it. One is trust in a central authority. The bank says I have $50 in my account, I have $50. Or the court says that I violated our contract and in compensation I owe you $500, I owe you $500. Central authorities are the standard way to do trust because they are relatively simple and they are reliable, or at least that's what central authorities tell us. But anytime that you have a central authority, that authority itself is a target for hackers or for people who want to abuse it. The other option is trust by consensus. What does this mean? We have a large number of people who care about a certain subject. We can poll them, see what they think, and accept what most of them say, accept the majority. The problem with consensus is that it is vulnerable to something called the Sybil attack or sock puppets, which is when you create multiple identities, which is very easy on a computer, and you make those identities agree with whatever it is you say, and that way you can fake consensus. To avoid this problem, consensus when it comes to computers requires participation to have a cost. And the two common types of cost that you'll see in the blockchain world are proof of work, which means that participation requires you to spend computer resources. For example, if you look at the Bitcoin blockchain, to add a block to it, you have to run a certain computation, what's known as mining. So only the people who spend the resources to run those computations can get to add blocks. The other option which Ethereum is moving towards is proof of stake. That means that when you participate, you have to have a monetary stake in the system, and you will lose it if it can be shown that you lied about something. Before we talk about Ethereum, though, we need to understand three building blocks: digital signatures, blockchains, and virtual machines. The way that digital signatures work is that they use two related keys. There is a private key, which only a specific person or program knows, and then there is a public key that matches the private key and is known to everybody. The private key is used to sign messages, and the public key can be used to verify them, and the mathematics promises us that it would be extremely difficult, as in turn the whole world into computers, run 1,000,000 years, and you still likely won't get there difficult, to create a signed message that would be verified with that public key unless you have the private key. A related thing to digital signatures is certificates. What happens is that I don't want to store the public keys for everybody in the world. That would be too much. So there are messages that tie a public key to an identity, and they are signed by the private key of a certificate authority that we trust to provide us with correct information. And of course, this works because the public keys for certificate authorities are well known. For example, every time you get a browser, they come with the browser. Another building block is a blockchain. Blockchains are blocks that include signed transactions, and every block depends on the previous one. So, if you accept block 4, it includes with it a function of block 3. That means you have to accept everything in block 3. Similarly, if you accept block 3, you accept block 2. If you accept block 2, you accept block 1. Now, why is this important? Imagine that I have a transaction on block 2 that I rely on. Anybody who relies on block 2, of course, has an interest in preserving block 2 and not changing it and rewriting history. But everybody who relies on block 3 also has such an interest, because if you change block 2, then that invalidates block 3, and that invalidates block 4, etc. That means that everybody who relies on a subsequent block has an interest in preserving my transaction, and that is why we expect the consensus to work, because there are a lot of people with an interest in keeping the truth and not so many people with an interest in a specific fake. An example of this you can see, for example, in Ethereum's currency called Ether. You get a public-private key pair, and that has associated with it an address, and every address has a balance that anybody can check. If I want to transfer a balance, I send the message, I, address A, hereby give you, address B, a certain amount of Ether. And it has to be signed by A, of course. I can't transfer your money from your account. And it has to be in a block where A has enough Ether to cover it. It would be a message that would be like a bounce check. I have $5 in my account and I give you a check for $10 is not going to be accepted by the blockchain, because obviously that means there's a problem there. Now, what would it take for me to renege on the transfer? Let's say that I'm an evil person. First, I would want to transfer my Ether to some sock puppet, another address that I control. Then I need to I send the message to I send the message to address B and convince address B that the blockchain will proceed with the message that transfers the Ether to B, and that I still have the Ether. But I need to convince the rest of the blockchain to accept a version where I first transfer the Ether to the sock puppet. That worked, now I'm out of Ether. And the transfer message where I transferred the money from the Ether from block A to block B wasn't valid because I didn't have the Ether at the time. This is what's known as rewriting history, but it is difficult because if I manage to convince address B that the blockchain will proceed with the message that transfers the Ether to B, then that is the message that all the nodes have agreed to and they're using, and I would have to convince most of the nodes to invalidate all subsequent transactions to get to the version where I first transferred the Ether to the sock puppet. Another point that's important when it comes to Ethereum is virtual machines. Computers can run on different types of equipment. You can run your computer on a vacuum tube, At least people did in the 50s. You can do it directly on transistors like people did in the 70s. And of course, today we use microchips. Computers can also run on other computers. In that case, you have a 100% deterministic environment. The same program with the same inputs would always produce the same outputs. That's supposed to be the case anyway, but in a physical computer, sometimes physics intervene and there are all kinds of electronic problems. In a virtual machine, that's a lot less likely to happen. Ethereum is to a certain extent like previous blockchains in that it uses signed messages in a blockchain to keep track of commitments. That is standard blockchain. However, and this is the important part, it also includes the EVM, the Ethereum virtual machine, to run programs. And those programs implement bots called smart contracts that can achieve various effects. So, what are smart contracts? They are bots that run on the Ethereum blockchain, and therefore everything about them is public knowledge. The program that they run is publicly known. Their internal state, all of their variables, etc., are known. And to send a message to one of those, you need to send it input, and that is also a blockchain message that is known. So, because all of these are known, the output is also known. Everybody can run the bot, can run the program, and see exactly what is the output, and therefore there is no room for subjective interpretation. And because nobody can modify the contract and nobody can run it to get an output other than what it is and get that accepted by the blockchain, a contract of this kind is unbreakable, or at least as unbreakable as the blockchain itself. Here is an example: lending with collateral. Requires a smart contract that receives information, let's say from me, the borrower, and you, the lender. It receives the agreed upon terms, and it needs to receive them from both of us because it needs to know that we both approve those terms. I also send it a software token that represents the collateral. Why don't I give it the collateral directly? Usually because the collateral is some kind of physical object. So it's the same as a home equity loan. When you get a home equity loan, you don't give the bank your house. You still need to live in it. And frankly, the bank doesn't want to have to manage real estate. Instead, you give the bank the title, which gives them the right to take the house from you, and you keep the physical object. And of course, you as the lender send the smart contract, the principal, and the smart contract verifies that the agreed upon terms have been agreed upon, that the collateral token is acceptable and all that, and then sends the principal to me, the borrower. Ideally, as the borrower, I am going to send back payments based on the agreed upon terms. The smart contract would note all of those payments and forward them to you, the lender. Let's assume that I didn't for some reason. In that case, you can send the smart contract, I want the collateral message. Now, the smart contract isn't going to just give you the collateral. It knows the terms and it knows all the payments I made because everything went through the smart contract. So it can see, did I default on the contract or not? If I defaulted, then yes, it will send you the token to you, the lender, the token. If not, then it's going to reject your request. The advantage of this system is that we have clear records of everything, and the only case in which you would need the court is if I, the borrower, claim, yes, I gave you that token, but that token didn't represent my house. That token represented my car, so you can take my car, but I keep my house, which is a lot more expensive. And if you made me sign a contract prior to that token does represent the house, it is going to be a very easy court case, a lot easier than the foreclosure process. So, conclusion, blockchains tie messages together. Because when you vouch for one of them, you also vouch for all the previous ones. And it works because of consensus-based trust. Most people have an interest in preserving the transaction history. Most people don't want to rewrite it. Certainly, most people don't want to rewrite it in exactly the same way. Now, these two are generic to every blockchain, but the important thing for Ethereum is that it includes smart contracts, which are bots that run on the blockchain that can be verified like a message. They cannot be modified. They leave no room for subjective interpretation, and being self-enforcing, they only require a court system at the interface to the physical world, which means that you can do a lot of things without litigation. And let's face it, if you can do without litigation, you're happier because it's very expensive.